Yep, we got the presentation clicker of all time. Yep. Okay, I think we're gonna get started here. So this one will probably be a bit shorter of a presentation. I don't know if anyone has any good ideas for an activity at the end, but if you do, at the end you should tell me. But yeah, Docker. So if you don't know what Docker is, it's a container engine. Essentially, you can take your services that you're running on your computer or just that you need to run. Oh, I didn't mean to go back. Um, and then you can isolate them inside of a Docker container. So it's sort of like a hypervisor. Like we talked about that a little bit last semester with Proxmox. It's kind of like a hypervisor where you can run a whole bunch of virtual machines on one physical machine, except containers are way lighter, like significantly lighter. You can run like hundreds of containers on a device. You can only run 10 VMs. Uh, so with Docker, the idea is that you can just package a single service into a container, and then you can just make that container, and then just put that container on your machine. And you do that for like 100 services and 100 containers, and they can all interoperate with each other really fancy like. Because of the way Docker's set up, it makes it a lot easier to install these containers. There's entire repositories dedicated to just containers or pre-built images for containers of services. They're also more secure because, isolation from the host, yada yada. And then there's less dependency conflicts because once again, it's just a container. You pull it down, you run it, you call it a day. So, anyone familiar with like operating system terminology has probably heard plenty of jokes about, fork process and kill child and stuff like that. And, when you run a service, you make a lot of child processes and everyone loves children. But the problem is children are really annoying to take care of. Like if you've ever babysat for someone, it's a pain. So with all our little baby services that we have, yeah, we're just gonna put them in the playpen and not worry about them, and that's basically Docker. Is now you don't have to worry about the kids running anywhere everywhere because they're all in their own playpens. So different parts of Docker. There are two main parts of Docker. That being images and containers. Images are isolated immutable file systems that can form the base of a container or another image. So essentially, it's just the root file system for what is essentially just a really small Linux installation that you can then layer other images on top of. So there's a base Debian image for Docker. And if you run that image, it's going to work perfectly fine. It's going to give you a shell in what essentially is a Debian installation. But there are other images for, say, like the Nginx web server or a Postgres database that are built on top of that Debian image. So now the people maintaining the Postgres Docker image don't have to rebuild their entire Linux file system from scratch every time. They just have to pull the latest Debian image, toss their files into it via a Docker file, and then they can just release that combined image as their own Postgres image. You can build images locally or you can pull pre-made ones from the internet. The largest repository, or not necessarily the largest, but the most common repository for this is Docker Hub. That's the one Docker uses by default. You can just Docker pull an image down and then Docker run the container. Speaking of containers, great segue, I know. Containers use an image as the base file system with additional mounts, port forwards, auto runs, and other container specific information. They can be created on the command line manually. You can do it with a GUI via Docker Desktop, or you can use Docker Compose, which is generally, in my experience, Docker Compose is the best way to do it because with Docker Desktop, you have to click the buttons and it's a pain. And you don't get that on most servers because GUI. And if you make it with the command line manually but via Docker run, if you ever need to remove that container and recreate it, which is the case whenever you update the container, which you should be doing relatively often. I'm not super great at that. I just updated my Vault Warden container the other day. It was 19 months old. 4-month uptime though, which is pretty cool. But whenever you recreate the container, you're going to have an issue because because you don't have like What was it? Oh yeah, because you're gonna need to recreate it with all the same parameters, like all the same port forwards and bind mounts and all of that stuff. Which means you're either gonna have to A, save the Docker run command in a script, or B, have a really good memory. And I don't know about you guys, but I am sorely lacking on that latter part. Can't even remember what I ate for breakfast. So, Docker images are primarily created via Docker files. You can create Docker images from scratch. You should not create Docker images from scratch because somebody else out there has you in mind and has lovingly crafted a base Docker image that you can pull in with your Docker file. So I am speaking from experience. Yeah, that was great. So for those, I haven't told this story a whole lot. I don't think I've ever told it at a computer club meeting. For CCDC Nationals last year, one of the injects that we had to do, so one of the things we had to do during the competition was migrate one of our services over to Docker. The organizers of the competition, in their infinite wisdom, gave us this challenge to migrate a service into Docker and then blacklisted Docker Hub on the firewall. So we couldn't pull Docker images. They did have repositories for various Linux distros available on the firewall, though. So what I ended up doing was bootstrapping an installation of Alpine Linux, which is a really small, lightweight distro. Like a base installation is like 10 megabytes. It's crazy. But downloaded that, bootstrapped a thing, bootstrapped like a base file system, and then I created a Docker image from scratch for that in order to migrate it. I think, was I the only one who did that inject, or were we the? Yeah, the next day they opened Docker up because enough people complained about it, but I don't think anyone got it done because. Oh, that's right. Yeah, they just Docker exported them because they didn't want to let it through the firewall. But yeah, nobody did it day two because day two is when you don't get to do anything fun and you just have to fix stuff. Regardless, Docker files. You use Docker files to build images specifically, not containers. Certain commands related to setting up the file system, or they contain commands related to setting up the file system. The most common of these is from, which specifies a base image. Essentially, whenever you run docker build with your Docker file, that from directive at the usually at the very top of the file is going to tell which image Docker needs to pull to actually, do stuff in. If you create an image from scratch, you're not going to have that, or it's going to be a local file. Run will run a command in the image. So essentially, it'll kind of create a little dummy container that it'll use to run the command inside the image, and it'll just kill and delete the container and go on to the next thing. Most common use for that is kind of like you see on the top right there. You run for a Debian image, you do like you do like apt-get update, and then you can apt-get install your actual file or your actual packages. This example here is, I think it's actually from the Docker documentation. Not 100% sure, but I haven't written anything with Flask in a while, and I haven't written a Docker file in a while, so I'm assuming that's not mine. But you can see it just apt-get updates, and then apt installs Python and pip. The next directive that's useful, copy. So you can copy files from your local file system into the image, which is what it does immediately after it pip installs Flask. It copies the actual Python script for the app into the image. Some more directives are environment, which you can use to set environment variables in the image. That's not super useful. Most of the time, you're going to want to set environment variables when you create the container and not the image. Expose allows you to document a port that the image listens on. This is the one kind of annoying thing with Docker is that the separation between images and containers leads to a lot of weird little discrepancies. And this is one of the biggest ones. This tripped me up a lot when I first started learning how to use Docker a few years ago. And it's one of the ones that I really consistently see people tripping up on is images don't have any ports forwarded. When you expose a port with the Docker file, it doesn't actually expose that port when you create the container. It's essentially just documentation for Docker to say, hey, this image wants you to expose a port when you create a container with it. So are you going to expose that? And when you're using the GUI, that works great because Docker can just pop up a little modal dialog and be like, hey, you're making a container with so-and-so image. Here's all the ports it wants you to expose. You want to give us values for those? And then you click create and it's all good. When you're using the command line, Docker does not do that. It'll completely ignore those and you'll have no idea that your container is completely isolated. So expose, it's still important to do because when you run a command like docker ps, it will tell you that you have ports that are unexposed. It'll just show up in the little exposed ports thing and it'll just tell you, hey, this port doesn't go anywhere. Of course, by then it's too late because your container's already made, but it's still good to document stuff like that. CMD will allows you to specify the command to run when a container using the image is started. So essentially, when you create the container, every container has what's called an entry point, which is once the container is all set up and it's ready to go, is the command that gets run inside the container. If you don't have one of those, your container is not super useful because at that point, it's just a file system that's just going to show a little shell when you start it up. So if you have, say, like a Postgres container or like this example Flask one, if you didn't have that CMD bit on the bottom here, you're going to run that container and it's just going to give you a little shell prompt. And you'd have to run it manually. Of course, when you're deploying with Docker, that's kind of against the whole spirit of the thing. So you can use the command directive here to specify the entry point for your Docker container. You can see it's kind of a weird format here. Every argument is kind of separated out into its own string. It's not like a bash shell where you have to like manually escape every like space character or whatnot. This is like I don't remember the exact format. I think it's something like a JSON array or like a Python array. It's that kind of syntax where it's basically just, list of strings. Makes it a lot easier to avoid or to not have like weird shell escapes and stuff, because that's another thing that trips up a lot of people when they first start using just the command line in general, is the fact that if you have a folder with a space in it, that has to be escaped every single time you type it, which gets annoying really quick, which is why you see a lot of people who use Linux on the regular avoid putting spaces in file names and whatnot. I don't even know if I have any spaces with file names in my or file names with spaces in like my documents folder. I always just use underscores by default now. But moving on to containers here, there's multiple ways to create a container. Docker run, you can use Docker Compose, and then there's Docker Desktop. Docker Desktop is the GUI, so it's great for dev work. If you're on your like laptop or whatever and you want to spin up a quick container to test it, that's great. That works great. Docker Desktop is actually really handy. It's not a complete waste because it's easy to spin up and delete containers, and you can go around and you can check the logs really easily. So it's nice for that. The problem is it's not good for much other than just dev work. So the main two things you're going to be using for creating containers are Docker Run and Docker Compose. The container file system is immutable and it loses changes when you restart it. So if you make a container and then you stop that container and you restart it, any changes to the file system that were made while it was running are going to go away. Those can be mitigated using container mounts. So there are two kinds of mounts: volume mounts and bind mounts. Volume mounts use a Docker like specific storage backend. So essentially, it's the same as a bind mount inside the container, but outside the container, accessing it is slightly different because a bind mount is a lot simpler. A bind mount literally just takes a folder on the host file system and makes it available inside the container at the specified point. So if, say, I have my Postgres container and I want my Postgres container to retain all of its information when I turn it off, which is going to happen eventually, I'm going to want to bind mount like /var Postgres data, wherever Postgres stores its data. I'm going to want to mount that in the container. Most containers, when you look up documentation for how to actually run a service through Docker, it'll tell you what you need to bind mount for it to work. If you don't bind mount it, you can use volume mounts, which technically also put stuff on the file system, but the way they do it is the way it's done is different, because a volume mount doesn't necessarily make the directory available on your host file system. Where if you have a bind mount, it's very explicit. This directory on the host is available in this directory on the container. A volume mount essentially just says, okay, I don't care where you put this on the host file system, but I need it to be here in the container. And that works nice for when you want like a config that can copy over to places really easily. The problem that arises though is if you ever have to access that data outside the container, it gets a little wonky. Because with a bind mount, you just cd into whatever directory. With a volume mount, you actually have to start another container that has access to the volume. So you do a volume mount with that same volume in another container. And then in that container, you have to exec a shell. So you basically just start up a container like the base Debian one, where it just gives you a little shell prompt. Then you can access it, but it's still goofy. So bind mounts are a lot simpler. Volumes are more portable, I guess. They're more abstracted from the host, is what Past Me put in the slides. So good on Past Me for being more eloquent. Networking. So networking in Docker is weird. So by default, Docker uses, it creates its own chains in IP tables. So if you've ever used IP tables for firewalling on a Linux system, you'll know that you generally have 3 chains: input, forward, and output. Most of the time, you really only use input and output because, well, things go in and things go out. Docker uses the forward chain, which is that third sinister chain that nobody really knows what it does. And that's because most of the time you're not using it. Most of the time it's completely irrelevant. The problem though is Docker, when you do networking, you are actually forwarding stuff, because the way IP tables does those chains is input is for packets that are external, or rather input is just for packets whose destination is your computer. Output is for packets whose source is your computer, and forward is for packets which are neither. So they're coming in and then they're going to go out again. When Docker does its networking and creates all of its containers, it actually creates a fake network that is just for Docker containers. So if you make a Docker container and then you check your IP addresses, and it does this on Windows too. You check your IP addresses using ipconfig on Windows, or like ifconfig or IP address on Linux. You're going to see an extra like BR interface, network interface, which is what's called a bridge. So Docker creates this bridge and it hooks it up to its own little virtual network where all its containers are able to access. And then it sort of like nats it out. And it's really weird, but it all goes through the forward chain. And because of the way Docker does stuff with the forward chain, you actually can't use the forward chain anymore. Or rather, you can, but it's undefined behavior, and your system might blow up if you touch it wrong. So it creates the Docker user chain, which is essentially just a copy of the forward chain, but for all of your Docker containers. So if you wanted to firewall stuff off in your Docker containers, ideally you shouldn't have to, because you can control explicitly which ports you need to expose. Then you can would add rules to the Docker user chain, and that allows you to actually operate on packets going to and from the Docker network with IP tables. The other fun thing about the forward chain is Docker user is still technically part of the forward chain, and the forward chain, because it doesn't guarantee packets are going in a specific direction, like input, the packets are going to come towards me. Output, they're coming away from me. Forward, they're going both ways. So you have to specify which interface your rules are actually operating on. It's like, okay, I want to firewall this specific container, this specific port on this specific container. Well, if I just add a rule for, this, if I say, oh, okay, if it's coming, or if it has this host in the packet and it has this, source TCP source port, then that's going to operate going both ways, and it gets really wonky really quick. Docker is integrated with Firewall-D, but not UFW. So I don't use Firewall-D and UFW a lot, but a lot of enterprise-grade systems come installed with them and have them operational at install by default. So Docker integrates with Firewall-D, but not UFW, which is just something to be aware of. With the Windows firewall, it doesn't have a forward chain, so it should just work normally. Once again, I'm not really sure about how the Windows firewall works. That's a problem for all the Windows people out there, which isn't me. I wouldn't want to touch something as disgusting as that. So the next fun thing is Docker Compose, and this is really where Docker starts to get cool, because a Docker Compose allows you to use a YAML file to construct an entire network or an entire like group of Docker containers just by creating this specific YAML file. So you can, if you have, say, like that example Flask application earlier, and that Flask application integrates with a database backend, rather than creating your own image and that has both Flask and the database in it, you can just have your one image with Flask in it, and then you can have another image which is just the like official Postgres image, and then you put both of those. You set your Docker Compose file up so that it creates a container with both of those images, has the right ports exposed. Now your Flask app can access the Postgres container through the internal Docker network. It also does a lot of cool stuff with host names too. So you can, like, if you name the service Postgres, then you can, in your Flask thing, you just say, oh, well, go to Postgres, and it'll resolve the domain name really easily. Excuse me. Let's see. So if evidently I can't click that. If I go, is it to the right? Which way am I supposed to move my mouse here? That's nice. Oh, now I'm lost. Okay, apparently it just hides my mouse. That's fun. Okay, so I'm just going to exit the presentation since this is the last slide anyway. And then we can hop over here. The example for Docker Compose was pretty big, so I didn't put it in the slides. Let's see. Oh, wait, it did open. Oh, it opened like 4. Well, that's a scam. Let's see. Come on. There. So you can see that it's got a bunch of, this is kind of like the Docker Compose, what it does. You can see it's got like a front end service, and then you have back end stuff, persistent volumes. Here's an actual example. This is a YAML file. If you've ever worked with something like JSON, YAML is essentially just a much more human readable version of JSON. There's a bunch of additional features, but at its core, it's just JSON, but easier to read for a person. So you can see here, there's like a services thing. This is a specification for the front end for a container called front end. It's going to use this example web app image. It's going to expose internal port or external port 443 to internal 8043. There are 2 networks, which is really fancy. I've not done a whole lot with network stuff in Docker or with Docker Compose, but you can create like multiple different networks and have your containers attached to all the different networks, which is really cool because you can do a lot of like service isolation. One thing I've seen is like if you have a bunch of Docker containers that you only want to be able to access like the internet over a VPN, you can create a Docker container that connects to the internet via that VPN and then basically does a NAT to the rest to an internal Docker network and then forwards any traffic on that internal network out to the internet over the VPN, which is pretty cool. But you can see there's a bunch of configs and stuff. Backend is a lot easier here. You can see the backend only connects to this back tier network, whereas the front end only connects to both of those. Uses a different image, and then specify volumes and stuff with the size. More configs down here. So yeah, it starts to get really complicated really quick, but most of the time for basic setups, you don't have to do a whole lot of stuff. Really, the big strength of Docker Compose is the fact that once you create this YAML file, it exists on your hard drive, so you don't have to memorize the contents like you do with Docker Run, and B, it's easy to just modify. You know, you want to add another container in there, just add another service, and you want to you want to shut everything down. You just do Docker Compose down, and it'll take all the containers specified in the YAML file, shut them down, and then actually remove them as well. You can do Docker Compose up to set them back up. It'll recreate all the containers, which as a side note will actually work well for upgrades because you just do Docker Compose down and then Docker Compose up. I think tac pull. There's a specific option that tells it to like force repull all the images instead of using cached ones. And it makes it a lot easier to do like container upgrades, setting containers up, and all sorts of stuff like that. So that's pretty much all I've got. It was a bit shorter. Anyone have any questions or anything? Okay. Thank you for coming. I guess I didn't put the QR code up. Let me see if I can find that real quick. The weirdest thing I've put in a Docker container? I haven't put another Docker container in a Docker. It actually doesn't let you do that. If you tried to do that, it would just tell you to put it in the same Docker instance that runs there. I did do the VPN thing that I was talking about earlier, which is kind of neat because then you can have like a service that might not be necessarily like secure or trusted, but you still need to run locally. You can have it run locally, but then actually still access the internet. Let's see, what do I actually have running? I haven't done a whole lot of weird stuff with Docker. Containers in general, though, can be a lot of fun once you start messing with them. I've ran like a graphical environment nested inside of a container using like a custom container thing that I wrote. Yeah, there's a lot of cool stuff you can do with containers. It's such a neat like concept or technology that you can essentially just run a fake little operating system inside the real operating system. So, yeah. Yeah, let's see. Where's the attendance? What's the date? February 4th. Can I download this image or there it is. Scanning for viruses. It's a QR code. Why do you need to scan it for viruses? It's a QR code. Look at it. Yeah, don't scan this. It has malware. Everybody pulled their phone up. Yeah, I mean, hey, QR codes, you can put like 4 kilobytes in that. That's massive right there. Okay, 4 kilobytes is so much data.
Like a bunch of QR codes. No, we did bring a bunch of QR codes.
We did. That was.
We pulled the QR code off the system by dynamically generating them off the user list because that was the most consistent way we had to grab a user list. The first day we used OCR.
Yeah, the first day I took a screenshot and put it in one of those Google like image to text things that lets you copy it out of the image. The second day I wrote a script that took all the like usernames or basically it would take a stream that you pipe into it and it would block those out into the chunks that were the biggest a QR code could hold, and then it would display the QR code. I'd scan it with my phone and then share the data in the QR code. I'd send it over a DM to someone via Discord. Yeah. And then I would hit the script, I'd hit enter, and it'd show up the next QR code. So it's just scan, send, enter, scan, send. There's like, I don't even know how many QR codes it took. There were a lot.
It was 200-ish.
All sorts of fun.
You can do Docker in Docker.
Oh, can you?
Docker has a container called DINE. They tell you it's a terrible idea. it works.
Yeah.
It's
I mean,
okay.
yeah. I mean, I do have actually I have LXC containers, which are like Docker containers, but it's like a different engine, but it uses a lot of the same technology as Docker containers. And on my Proxmox server, I have a bunch of most of my stuff is in LXC containers, but it's also mostly almost all Dockerized, which means I have essentially a bunch of Docker containers inside of a bunch of LXC containers inside the hypervisor. So I guess Malachi, there's your answer to the weirdest container thing I've done. Yeah. Yeah, I wish that something like Proxmox had like Docker support, but I also kind of don't because I like being able to have like different container. I wish there was a better way to do like yeah, because essentially all it is like, okay, well, here's a Docker compose file. I want to run this in its own isolated Docker instance. I wish there was an easier way to do that. Were you raising your hand for a question or are you just stretching? Okay,
No one me, I would just yell at it.
that's fair. Okay. Podman? I've never used Podman. I do know, I mean, I know a little bit about it. It's essentially like a daemonless version of Docker. It is, I think it's compatible with Docker, right?
Exact same syntax and
Yeah.
everything, like, drop it in place.
Mm-hmm.
A little bit, but it's pretty much exactly the same Docker. I do like that you can do with this a lot easier. Because it uses like it uses what do they call it? User
Namespaces?
namespaces
Yeah.
instead of the socket or whatever that Docker uses.
Yeah. Well, because Docker does, like, it still has the daemon, but the daemon is mostly just for, like, managing the actual containers. Whereas anyone can technically create a namespace on Linux. Like, that's not restricted to root. It's just that the way Docker was built, the way Docker does stuff requires a daemon running as root. And in order to actually, and in order to communicate with Docker and make a Docker container, you have to communicate with the daemon.
User namespaces is they bring unprivileged user namespaces specifically. They bring your issues.
Yeah. I mean, there's always more security issues down the
The
road.
trade-off is that, for example, Flatpak also uses things for sandboxing, and Chrome uses it for sandboxing as well. There are like security vulnerabilities that are related to using that for privilege escalation, and like at the same time if you disable it, then you have to run
Yeah.
because you want to use Flatpak, you have to fix it to
Mhm.
use the WID set your ID back to it's the set your ID issues and stuff.
Yeah. Yeah, set UID is a whole nother can of worms. I was reading a thing the other day because I tried to set I wrote a script that I wanted to make set the suid bit on, and apparently Linux doesn't let you set the suid bit for scripts that use a shebang, right? You know, you do like bang words. The little hashtag, the octothorpe, that funny thing, shift 3. That exclamation point, then your executable to run it with, and you can make like a Python script run just like a normal command. I was trying to set the suid bit on one of those, which for those who don't know would make it so that whenever I run that binary, it will run it as the owner of the binary rather than me. That's how sudo works to actually escalate your privileges. Is sudo is owned by root and has the suid bit set. When you run sudo, it always runs as root, and then once you've successfully typed in a password, it runs your command, which is really kind of interesting to think about from a security perspective, because if you can run sudo and there's some sort of a remote, like arbitrary code execution vulnerability in sudo before it runs or before it checks your password, then you just run code as root, which is always fun to think about. But yeah, there's a fun race condition when you have like a binary, or when you have the shebang binary with suid, because what the Linux kernel does when it actually runs those when it runs a binary or an executable with a shebang is it opens the executable to read it and to read the code into memory. it sees that the first two bytes are octothorpe exclamation point, and it goes, oh, okay, it's got a shebang. So it pulls in the rest of the first line there, finds the interpreter to run. It closes the initial shebang executable. And then it starts up the interpreter with the correct arguments to run it. And then the interpreter will then, on its own, it'll open up that file again. So the problem then is if you have a suid bit, like a shebang suid bit executable, you start it, the kernel loads it up, sees that, and then shuts it down, and then starts up the interpreter. And then the interpreter is responsible for reading that, which means the file actually gets read twice, which means there's like a weird race condition there where there's a possibility for privilege escalation. So, yeah, really weird. I was wondering why my script wasn't working the other day. That was a fun, like, 20 minutes of debugging. Oh man, what was it? Oh, I was trying to do a really lightweight replacement for like sudo. That basically I just drop the shell script off on the on whatever like machine I was working on, and then it would have a hard coded password in it and have suid bit set, so I could just use that instead of sudo. So then I'd only need to privesc on the box once, and then I'd be able to do it. Yeah, this was for Scout. This was for a CCDC. Yeah, no, I never mentioned this to anyone because that's how quickly it died, and was about those 20 minutes. But yeah, because I was having trouble with privesc, so I'm like, you know what? I'm gonna make it so I only have to privesc once instead of for every command, and then I can just hard code the privesc for the rest of them. But unfortunately, that didn't work, and I didn't want to ship a compiled C binary with it. So yeah.
Double down on Linux. Our repo's already a gig.
Oh yeah, part of that is home_alone_2.avi. What?
Run the whole run. We're in the Windows meeting. Igor just kept trying to hit your
Yeah, it's a Linux command. It's a Linux binary. Did you have Fuse? Run it right now? Okay. Where's my thing? It's not an AVI file. Man, you window users are all like, oh, it's a .docx, it must be a Word document. But I hate to break it to you, but that's just a .zip file in a trench coat. Yeah. So if I hop over to if I go over here, if I cd to documents / what did I think it's an ACE.
The year we're not in person for that.
Yeah. So if I go into where did I put it? Oh, I put it in MISC. Yeah, so it's not actually an AVI file. I hate to break it to you. If I /home alone 2, I never actually tested this. That's interesting. Home Alone 2.avi not found. Oh, it's because I have to if I mv it to test.app image and now I run it. See, I'm remembering my own code. If it ends in .app image, it pulls up a shell. And because this is actually Scarf, which is that custom container tool I was talking about earlier. So yeah, that actually has like every single that's the one with all the replacements for service binaries. That's why it's 250 megabytes.
Good, but also this means it worked because they genuinely thought it was.
That's great. There's also there's also fast fetch, which if you run will actually just fast fetch, but you'll see it's a little weird because I'm not running Alpine, I'm running Arch. And that's because that fast fetch binary is another Scarf binary that is much smaller. That one doesn't have any of the services in it, but it's got some of the nice essentials. Let's see. I think we've gotten off track enough that I can say that the stream is done. Yeah. Speaking of which, hello to any people who are not at DSU watching this stream, which I doubt there are. Congratulations for getting the CCDC trade secrets.